An interval in music is the distance in pitch between two notes. And an interval's name has two parts, a quality and a number. Now the quality is going to be a word like major, minor, perfect, diminished, or augmented. And the number is going to be an ordinal number like second, third, or seventh. You put these two parts together and you get the complete name of an interval. So major third, perfect fifth, augmented sixth, and so on. Now of these two parts, it's the number that is much easier to determine. So that's where we'll begin. To determine an interval's number, all you have to do is count up the total number of lines and spaces on the musical staff encompassed by the two notes, including, importantly, the location of the bottom note and the location of the top note. So let's look at a couple of examples. We begin with this one, F to C, and we'll begin by counting from the bottom note. So this bottom note lives on the bottom space of the staff. We'll count that location as 1. We'll count the next line as 2, the next space as 3, the next line as 4, and finally, this space occupied by the top note, the C, as 5. And since we've counted a total of 5 lines and spaces, this interval is therefore a fifth. Let's take this next one, an F down to a D. It happens to be a descending interval, it happens to be in bass clef, but neither of those things matters in terms of our method. We'll still begin counting from the bottom note upward. So the bottom note is the D, it lives on this line, we'll count that as 1, the next space is 2, and the line occupied by that F gives us 3. So we've tallied up a total of 3 lines and spaces. Therefore, this is an interval of a third. So pretty easy. Let's take a couple of special cases now. These two Ds. They happen to be a harmonic interval in the sense that the two notes are played simultaneously, but that also doesn't affect our method. We're still going to begin counting from the bottom note and work our way upward. That line is 1, the next space is 2, 3. We'll use our knowledge of ledger lines now. This one's going to be 5, 6, 7 would be the line note. And finally, 8 is that space note, exactly where our top D is. So we've tallied up a total of 8 lines and spaces, giving us an interval not of an eighth, but in musical terms, an octave, which is a word that I'm sure you're familiar with. Let's do one more special case here, an E to an E. We're still going to use the same method here, but it just so happens that both of these notes live in the exact same location. They're both on the bottom line of the staff. So we'll count that as 1, but then we're done. We have nothing more to count. So this is an interval of a first, I suppose, but in musical terms we call it a unison. That makes perfect sense, right? When you are listening to a choir and all members are singing exactly the same pitch at the same time, they're said to be singing in unison. Now you may have noticed that so far we've been dealing only with natural notes. That is a regular F to a regular C, a regular F to a regular D, and so on. No fancy things like sharps or flats. But here's the deal. Accidentals, sharps, flats, and so on, have no effect whatsoever on the number of an interval. So I could write sharps and flats and double sharps and double flats in front of these notes all day long, and that would not change the fact that this is still a fifth, this is still a third, this is still technically an octave, albeit an unusual one, this is still technically a unison, albeit an unusual one as well. So accidentals do not affect the number at all. Now a tiny bit of housekeeping here. It's totally fine when you are labeling intervals with their number to drop the TH, drop the RD, drop the VE, and certainly you don't have to write out the word unison. You can just write the numbers and that's perfectly sufficient. However, when we're talking about them, we'll still refer to them by their official names of fifth, third, octave, and unison. Now, as you get more practice naming numbers of intervals, you'll find that you can easily eyeball the number of certain intervals just by sight and not by counting up lines and spaces. So let me give you a couple of examples. All seconds look something like this, a space note followed by the very next line note, or a line note followed by the very next space note. Thirds always look something like this, 2 consecutive space notes or 2 consecutive line notes. Fifths always look something like this, a space note and a space note with 1 space in between, or a line note and a line note with exactly one line in between. All right, now it's time for a very brief quiz. You're going to see a few intervals, and your job is to determine the number for each one of them. So for instance, you might see something like this. We got a B flat to a C sharp. Ignore the accidentals. They don't matter for now. Just count up your lines and spaces, and of course you come up with the number 2 or the interval of a second. So the problems will be displayed for a few seconds, followed by the answer key. So feel free to pause the video while you work out the problems and then resume to see the answers and then to continue on to the next segment. The most common interval numbers are 1 through 8, or unison through octave. And these 8 numbers are divided into 2 categories, the perfect category and the imperfect category. In the perfect category, we have 1, 4, 5, and 8, or unisons, fourths, fifths, and octaves. And in the imperfect category, we have all the rest, seconds, thirds, sixths, and sevenths. Now, there's kind of a long music history explanation as to why we have these 2 categories. Suffice it to say that a long time ago, when composers were constructing harmonies, they tended to favor these numbers and thus deemed them perfect. But for our purposes, the really important thing is that these 2 categories allow us to determine which qualities go with which numbers when we are giving the full name of an interval. So imagine that you're looking at a piece of music and you encounter an interval of a unison, a fourth, a fifth, or an octave as the number. There's a good chance that its quality is going to be perfect, abbreviated with a capital P. All right, now if on the other hand, you encounter a second, a third, a sixth, or a seventh, one of these imperfect numbers, chances are good that its quality is going to be either minor with a lowercase m or major with a capital M. Now, let's stay with this imperfect category for a moment. It stands to reason that a major interval is going to be larger than a minor interval. So for instance, a major sixth is likely going to be larger than a minor sixth. And so let's hear it in action. Here's a major sixth, and here's a minor sixth. Now, how much bigger is the major than the minor? It's exactly 1/2 step bigger. So for the moment, let's just imagine the minor quality is maybe small in size and the major quality is perhaps large in size. Now, a moment ago when we said that if you see one of these, chances are the quality is going to be either minor or major, but that doesn't cover every single possible case. Let's say that you've got a sixth, but it's a particularly large sixth, let's say extra large in size. Its quality is going to be augmented, abbreviated with a capital A. Now, if on the other hand you see a particularly small sixth, say extra small in size, its quality is going to be diminished, abbreviated with a lowercase d. Now, how much bigger, how much smaller? Well, the augmented version is exactly 1/2 step bigger than the major version, and the diminished version is exactly 1/2 step smaller than the minor version. So if you've been keeping track, you realize that as you read from left to right, the interval is getting larger by 1/2 step each step of the way. So let's hear this in action. Here is a diminished sixth. Now here is a minor sixth. Here is a major sixth. And finally, here is an augmented sixth. Now, this pattern holds true not just for sixths, but for all seconds, thirds, and sevenths as well. Okay, now let's go back to the perfect category. We said that if you encounter one of these numbers, chances are good that the quality is perfect, and let's just call that maybe medium in size for right now. But let's say that you have a fifth and it's a little bit on the large side. Its quality is going to be augmented, again abbreviated with a capital A. Now, if on the other hand you have a particularly small fifth, small in size, its quality is going to be diminished, again abbreviated with a lowercase d. How much larger, how much smaller? An augmented version is exactly 1/2 step bigger than the perfect, and a diminished quality is exactly 1/2 step smaller than the perfect. So again, as you read from left to right, the size increases by 1/2 step each time. So let's hear these in action. Here is a diminished fifth. Here is now a perfect fifth. And here is now an augmented fifth. And this holds for all unisons, fourths, and octaves, as well as fifths. Okay, let's take a brief step back and just make a couple of important observations. You'll notice that from this information, the perfect quality is exclusive to unisons, fourths, fifths, and octaves. That is, there is no such thing as a perfect third, or a perfect sixth, or a perfect second, or a perfect seventh. They don't exist. Perfect is exclusive to these numbers. Similarly, minor and major are exclusive to these numbers here. You can never have, for instance, a minor fifth or a major octave. They don't exist. And you can also notice that the diminished and augmenteds, you can have a diminished or augmented anything. They are not exclusive to one category or the other. Now, one other thing to think about based on this information, you can kind of see how minor and major are opposites of one another. In our case, maybe small size and large size. You can also see how diminished and augmenteds are opposites of one another. On this side, we have an extra small versus an extra large, and over here, small versus large. Now, what about perfect? Well, perfect has no opposite. It's right there in the middle. So these ideas will become important when we deal with interval inversion in a little while. But for right now, let's summarize what you know, because you know quite a lot about intervals already. You, of course, know how to calculate the number of an interval by tallying up the total number of lines and spaces on the musical staff encompassed by the two notes. And given that number, let's say it's a unison, fourth, fifth, or octave, chances are good that it's perfect. If it's smaller by a 1/2 step, it's diminished. And if it's larger by a 1/2 step, it's augmented. If you come up with one of these numbers for the interval, chances are good that it's either minor or major. If it's 1/2 step smaller than minor, it's diminished. And if it's 1/2 step larger than major, it is augmented. So let's take a very brief quiz. You'll see a few intervals, and your job is to, yes, of course, determine the number, but also make an educated guess as to its quality. So for instance, if you see something like this, B flat to a D, you can, of course, pretty easily determine that that is a third. And now comes the educated guess. Well, if it's a third, chances are good, let's put a question mark maybe, chances are good that it is either minor or major in quality. It's not a guarantee, but those are two good guesses right there. So as before, you'll have the problems displayed for a few seconds, followed by the answers. So if you need to pause while you work, you can do that and then resume to check your answers.